My name's Chris, and I repair my own audio equipment, and I also show you how to repair yours. So let's get started. Pioneer Spec 2 power amplifiers don't get a whole lot of love when it comes to sound quality. You go out there in these audio forums, and many people will say, my Spec 2 just sounds terrible, I got rid of it, compared to my other equipment. Very rarely do you see somebody say it sounds good, and there's a reason for that. One reason behind why Pioneer Spec 2s, for the most part, don't sound good unless they have this one thing done to them. Fix that one issue and you will have an outstanding power amplifier that will stand up to any piece of audio equipment, vintage or modern. If you haven't already, please subscribe. The problem component is a reed relay designated RL1 on the Pioneer Spec 2 schematic. Here I'm holding RL1, this reed relay, and along with that I put a little bit of a video in here because I went ahead and took it apart. I was just curious, like, what's inside this relay. So I went ahead and stripped the paper off. I got through the windings and I opened up the case, and there's what I found. And if you guys want to know anything more about reed relays, just do an internet search and you'll find tons about them if you're interested. The exact reed relay is not available, but as I tell you guys, even if you can't get the original one, there's almost always a replacement available. And this is the replacement I use. It's not a direct replacement. You've got to do a little bit of a modification, but it works fine. This relay, when not operating properly, which after all these years is most of them, what it causes is a reduction in the bias current, which means that the amplifier idle current is extremely low or practically non-existent. This Spec 2 that you see in this video only has 2 millivolts of idle current in the left channel. It should be 30. The right channel has 30, but the left doesn't. The amp looks perfectly happy. The gain controls are exactly the same position on both channels, except one amplifier assembly is way out of spec. And I'm no engineer, but I do know that these units can hide a lot of problems with their negative feedback circuitry, but there's only so much hiding they can do. And when you're only running 2 millivolts on one channel, that is going to affect the sound quality. To get to the power amp assemblies, first, have to go ahead and take off the top cover, and then put the unit up on end, and go ahead and take the bottom cover off. And then once get the bottom cover off, then can go ahead and undo the wiring harnesses, both at the top, and there's also a couple connectors down at the bottom that have to come off before the assemblies can come out. Then just loosening 4 screws at the back will take out each assembly. Now, you've got to remove the thermal bias diodes. That's what I'm doing here, because if you don't, and you go to take off the board from the heat sinks, you'll bust the wires on those. And I'll just say that's a bad problem to have if you do that. So that's probably the most critical thing if you try to do this, is don't forget to take those guys off. They're very delicate. The wires are very, very thin, and those thermal diodes are not available any longer, and you're in big trouble if you lose those. The amp is not going to operate without them. Then you remove 4 screws from the board that attaches it to the heatsink so that you can get to the board to replace the relay. I used my desoldering tool and my soldering iron to work the old relay out. As I mentioned to you guys before, just take your time with this. Don't rip the eyelets out. Make sure that it's nice and loose before you pull it on out. and you won't cause yourself any issues. It's time to put in a new one. And what I'm going to do with the new one is mount it upside down because, as I had mentioned, it's not a direct replacement for what I have. Once you get the old relay out of the power amp assembly, then you can install the new relay, as I mentioned, upside down, and you can attach it to the board with a little bit of epoxy. Then you've got to attach 4 wires, and those wires will go through the original holes that the relay came out of. So if you look at the picture, you'll notice that the 2 inner pins, I've run the wires to the holes that are closest to the new relay, and the other outer pins, those are run to the holes that are closer to the existing relay. This is how it needs to be wired up to operate properly. After installing the new relay, I went ahead and assembled the power amp assembly back together and reinstalled it into the Spec 2. And then I removed the other channel, and I'm going to go ahead and do the exact same thing. I'm going to remove that old relay and put in a new one. I'm going to say it one more time because it's so important. Make sure you loosen the screw for those thermal bias diodes and you get those guys out of the way before you start moving this assembly. And just as important, when you're finished with the assembly, don't forget to reattach those diodes. After getting the Spec 2 back together, I went ahead with the testing. After replacing the defective reed relay, you could set the bias on the left channel, no issue at all. And of course, you saw while I was in here, I went ahead and did the right channel also, even though it didn't appear to have the same issue. I want to show you how this Pioneer Spec 2 powers up. And I thought a good way to do it would be with a graph instead of just with a meter, and to show you how time affects the idle current. So I have a graph, and on the left you'll see a picture of the Spec 2. That'll be powered off. I'll power it on. Below that is my multimeter, and to the right you have a graph, and that's going to show you both the time period and also the voltage. So the horizontal part of this graph is the timeline, the vertical part is the millivolts. So you're going to see that graph moving as time goes on. And this is how a Spec 2 should power up properly. And also it's going to show you why you should allow your vintage audio equipment to warm up for a period of time before you check the idle current. What I'm about to show you took about 30 minutes to complete, but I'm going to show you what I did in less than 3 minutes. I've hooked my meter leads up to the test points that are shown in the Pioneer Spec 2 service manual. And what we're looking for between these 2 points is 30 millivolts. All right, I'm going to get started. I'm ready for the power up. It's still in protection, so there's no activity. The red light should go out in a minute. And there it goes. And now all of a sudden you see the meter start to move and the graph start to move, and you can see here on the graph that again the horizontal line is the time, and it's been running 20 seconds or so, and you can see that the voltage is going up. What's nice about the graph here is you can just see it over time. I'm not going to run through this whole graph, this 30 minutes as I indicated, but I want to show you about the first minute and a half, because it goes up fairly rapidly, the voltage, but it doesn't get anywhere near its 30 millivolts either. And so this is why it's important on a Spec 2 or any vintage amplifier or receiver to let it run for a little while. Usually a half an hour or so is sufficient. You'll see here coming up before too long, when I cut off here at a minute and a half, I'm going to jump ahead to about 13 minutes. Right now you can see the voltage still going up pretty steadily. And you can see there on the graph it's just consistently going and going. But coming up here, you're going to see this graph really flatten out over time. it'll be changing here. There we go. I just went up to like 13 minutes. If you look down at the timeline, now we're up at 13 minutes. And if you go all the way back to the left at a minute and a half, when we were around 18 millivolts, now we're here at 13 minutes at about 27. So we're much higher, and you can see this graph really flattening out quite a bit. And I'm going to jump ahead from 1320 here all the way up to over 30 minutes to show you the difference between 30 minutes and 13. Not very much, right? In 20 minutes, it only moved, you know, a millivolt and a half or so. And now you can see that that line is really flattened out. So you can see from the graph at about 20 minutes or so, it stabilized, I would say. It changes a little bit, and you got to keep in mind these are just very small movements, so that's all normal. And this amplifier is warmed up and it's ready to go, and it's right where it should be. So this is what that reed relay did. It allowed us to get enough idle current for this amplifier to operate properly, and more importantly, to sound great. If you enjoyed this video, I'd appreciate a big thumbs up down below. If you'd like to leave some comments, I read them, so please do that. And to my present subscribers, thank you so much for watching. To you guys who are not subscribers, if you'd like to see more videos like this, I'd appreciate if you did subscribe. Hope you all have a good day.